Here's the answer key for the homework. So I'm just going to work through these. It's going to take a long time, but I figure you won't mind. So for question number 1, we have the sequence 1, 6, 11, 16. First thing I need to do is determine what kind of sequence this is. And if I look carefully, I'll notice, hey, it's got a first common difference of 1, so that it's an arithmetic sequence. And in addition, it also tells me the D, the common difference, is 5. So if I use the formula for a arithmetic sequence, I have u sub n equals n minus 1 times d plus u sub 1. Well, in our case, the d is 5 and the first term is 1. So when I simplify that down, I have 5n minus 4. So there's parts A and B. For 2, I have the sequence 1, 2, 4, 8, And I notice here, if I look carefully, this is a geometric sequence. Notice each term is being multiplied by 2. In addition, it tells me the common ratio is 2. So if I take the formula for a geometric sequence, u sub n equals u sub 1 times r to the n minus 1, and I plug in, well, the first term is 1, common difference is 2, and if I simplify that down, I get u sub n equals 2 to the n minus 1. So 3, -4, 8, 12, 16. If I notice here, I have signs that are alternating from one to the other. Well, looks like an alternating sequence to me, especially since we're not multiplying by a constant, right? If I multiply this by -2, I multiply this to -2, I don't get, it doesn't work. So, since it's alternating, I'm going to think about this as some sequence h sub n times a different sequence k sub n, where h sub n is just going to be the signs of my sequence. Well, since these are signs, this is just a geometric sequence. We're multiplying by -1. So that tells me h sub n is h sub 1 times r to the n minus 1. Well, the first term is -1. The common ratio is -1. It's the n minus 1. And if I multiply these together, I get -1 to the n. My k sub n, then, is going to just be the magnitude of the terms of my sequence. So I've just dropped all the signs. Well, here it doesn't take much to notice that this is arithmetic. And I guess I should mention that this one over here was geometric. And since it's arithmetic, I can say k sub n equals n minus 1 times d plus k sub 1. So k sub n equals n minus 1 times 4 plus 4. Or if I simplify this down, it's just 4 to the n. So, again, remember that u sub n is h sub n times k sub n. And we said that h sub n was -1 to the n. And k to the n is 4n, so there's my sequence. 4, I have the sequence 2, 9, 28, 65. We did this already. So you can check that other video, but it was that, if you don't feel like checking. Oh, and there's a polynomial sequence. You guys were all complaining about not being able to do the calculator part. So I made that video for you, just for you, complainers. So the number 5, we have the sequence shown here. I noticed that, well, I can't just be multiplying by a half. And certainly there's no way to add 2/3. I mean, well, maybe there's a way to add these, but like it's not convenient. This is a rational sequence because it's got, I'm just going to think about it that way. really easy if we do it that way. So I have some sequence h sub n over some sequence k sub n, and my sequence h sub n is just the sequence of numerators. That's really easy. And, well, that's just the sequence 2. Just a constant sequence, if every term is 2. Pretty stinking boring. If I take my sequence k sub n, oh, well, that's a super easy arithmetic sequence. And I can say then k sub n equals n minus 1 times 3 plus 3, or k sub n equals 3n. So my sequence u sub n is 2 over 3n. Boom. Done. Number 6. This is how fast you guys should be doing your homework. I'm just kidding. I'm a pro. Don't try this at home. Well, actually, I really do want you to try this at home. That's kind of the point of doing homework, is the home part of it. Again, I noticed that this looks weird. It's a pretty obvious rational sequence. I mean, it doesn't look like it's arithmetic or geometric, and it's obviously not geometric and arithmetic. I mean, if it is, it's just kind of too tough to tell. So again, I'm going to have my sequence of numerators, h sub n. And I notice here that we're just adding 2 each time. So, well, that tells me that this is arithmetic. And that is going to be n minus 1 times 2 plus 2, or h sub n just is equal to 2n. And then I have my sequence of denominators, 3, 4, 5, 6. Oh, well, this is just plus 1 every time. That's pretty easy. So again, arithmetic. So this one probably was able to write, since it's arithmetic over arithmetic, was probably able to write this. But, ooh, good lordy, it wasn't going to be obvious what that constant difference was. And those adding of fractions. I mean, you could have tried it. It's probably wasn't that hard, but I don't know. It seemed like a clear case where it would be easier to think about it as a rational sequence. And I just write my final answer as my h sub n over my k sub n, just like we did in the previous one. Now we're on to 7. Good golly, Miss Molly, Mr. Kulik, what were you thinking when you gave us all of these rational sequences? Again, shouldn't be a shocker. You could think about this as a rational sequence, but boy, that's a lot of work. You might have also noticed that this is pretty obviously, we're just adding 1/4, although you could have done it as a rational sequence, just like we did the other ones. But this is pretty easy arithmetic sequence. It just looks like it's a rational sequence, and you could have treated it as one, but it's easier to just, in this case, to do an arithmetic one, or treat it as arithmetic. And when I simplify this down, I get n over 4. Or you could call it 1/4 n, like I was starting to write, and then I just decided that it'd just be easier to write as n over 4. It's less symbols that way, and like any good mathematician, tend to be a little on the lazy side. And by lazy, I mean I just don't like to write a lot. Oh, that's a 3 there, huh? And this one is one where it looks like maybe Mr. Kulik made a mistake when he typed this problem set up. Because this one, I'm not sure, looks like it's going to be doable, but let's try it. So this, right away, I'm going to note that this is probably going to be rational. And sequence of numerators, and this is the place where I'm in a little bit of trouble here. That if it is that numerator sequence it's going to be, well, this is a first, it's my second. Oof, it's a polynomial, third the difference. That's no fun. And we saw how to do this earlier, so I'm going to just kind of express route straight to the matrix. And then I have a 8, 4, 2, 1, 3, and then a 27. That's 3 to the third. So the third degree terms, and then I have my fourth term. Oops. Oh yeah. 7. So again, what I did is I plugged in first term, so I did 1 for n's, and then what the term, or what the value of that term was. And then second term, I put in 2 for n's, and then what that term was. And then 3 for n's, and what that term was. And then 4 for n's, and what that term was. And we'll fire up our old friend Graphemic Calculatron here. And ask him for his help here. So I'm just going to use the one that I had before. The only column I really have to change is not that one, is this one over here. Oh, I just need to change this. Oh my gosh. Is this solutions column. And if you just press down, I'm just going to type that in. And if I press second and enter, it's going to bring up the last thing I had done. And oh, brother, where art thou? Let's not use those. Let's get some fractions there, because those decimals I recognize as all sixths. If I press math and then use the fraction command, it'll give me those as fractions. And if I scroll over, I get some pretty terrible looking answers. So this one looks like a pretty clear Mr. Kulik, whatever he was doing kind of messed it up, but that's okay. It's just, we have an answer, just kind of a pain in the butt. I'm just going to recopy that a little neater. So my, oops, this was, we named this guy H sub n, no, not U sub n. So I have negative 1/3 n to the cubed plus 19 over 6n squared minus 41 over 6n plus 5. Yuck McDucks. And then my denominator sequence, well, that's considerably easier. Those are zeros. This is just an obvious arithmetic one. Did I label this one back here as polynomial? I probably should have done that. Sorry for jumping around on you guys on this one. I just made a mess out of it in general. Okay. Oh, we should probably finish solving this before I write my final answer. And hopefully that k sub n equals 10n. Super obvious. So I have negative 1/3 n to the cube plus 6n squared minus 41 over 6n plus 5 over 10n. Gross, if I simplify this down, I get negative n squared over 30 plus 19n over 60 minus 41 over 60 plus 1 over 2n. I guess if I want to simplify it down, I mean, this would have been fine for me, but yuck, I think I made a mistake in terms of what I copied or how I made that problem up, or if, I don't remember if I stole that from another textbook, or if I tried making that one up myself. Either way, I failed. That was pretty terrible. Nothing I would ask you to do would be that difficult on the test or quiz, but I wrote it, so I'm going to finish it. So the next one, really obvious, arithmetic, common difference 0.7. That's a 0.7. I know it's kind of hard to read. So u sub n equals, oops, not 3.1, that's 0.7n, and then plus 2.4. And 10, we have 4.2, 2.6, 1, negative 0.6, negative 2.2. So if I look at this, it looks like what we're subtracting 1.6. Yeah, and that's happening every time, isn't it? Well, that's convenient. So this also arithmetic. So u sub n equals negative 1.6 and minus 1 plus 4.2. And we'll simplify that down. Negative 1.6n plus 2.6. Nope, not plus 2.6. Try again, stupid. 5.8. And we'll move on to set 2. As long as we're doing these, I might as well do them all, because I'm not going to want to do it again later. Let's see the next one. I have the sequence 1.2, 4.2, 9.2, 16.2. Well, I added 3, add 3 again, and it's not arithmetic. I don't know if it's geometric. There doesn't seem like there's going to be a number that's going to do that. So let's just assume it's polynomial. You might want to be tempted to think about this as rational if we rewrite these all as fractions over 5, and you can probably do that, but I'm going to try it as a polynomial sequence because that looks pretty doable there. And it is, right? So I do have polynomial sequence. I have a second constant difference. And so we can go ahead and write our matrix. And again, folks, I'm going to cheat and go straight to the matrix. If you have to write out the system, in fact, I encourage you to be writing out your systems. I'm just a professional math teacher. So I'm going to abridge some of the work here for some of these places. But if you're not quite sure on how I got those numbers there, write out your system. It should be pretty obvious after you do that. I'm going to go in and, go in and edit my matrix now. Because again, like maybe you could do this by hand. Gosh almighty, that's a 3 by 4, not a 2 by 3. But I'm not about to do that. And I'm just copying the matrix in just like we see it there. So no mysteries, no magic, no tricks. Just me typing in my good old friend. And that's good. So get on out of there. And again, I'm going to press second and enter. And I don't want to do fraction. I want to do what I did before that. So I'll press second enter again, and it brings back up RREF A. And so this is an interesting answer. So notice I get this 1.2 e negative 13. Well, that means 2.8 times 10 to the negative 13th. So that's decimal point, 13 zeros, and then a 2.8. That's basically the same thing as 0. I'm just going to write it as 0. It's really kind of like an artifact of the calculator's rounding system that's going to do. So this tells me that I have u sub n is n squared plus 0 plus 0.2. So there's my polynomial. Next one here, number 12. I got 9, 16.8, 24.6, 32.4, ... Well, let's see here. That's plus 7.8. And that's plus 7.8. Aha! And then a plus 7.8. That's good. Arithmetic it is. And so u sub n is n minus 1 times 7.8 plus 9, or u sub n equals 7.8n plus 1.2. 13. And sorry if I'm going too fast for you folks, but that's why they make the pause button, right, on this thing. Or you can rewind it or whatever. And notice here, another arithmetic one. These are so easy. Hope by now you get pretty good at these. And notice I'm just kind of giving up, even talking my way through them. That's plus 3 minus, so that's a, oops, yeah, plus 1. Yep. And that's good there. Watch your negatives, so easy to make a mistake. And again, like if I'm going too fast and you need to do something, like you should go back and you know, pause and rework some stuff. So this this is impossible because I've made a typo here. There should be no 6 there. I don't know. Must have been early. I was probably typing this at 6 in the morning. So you should notice that this is clearly geometric. The R value is 2, and probably some of you don't even have to use the equation to get this. And I have 2 to the first times 2 to the n minus 1. If we add the exponents, 1 plus n minus 1 is just n. What's that? So sorry for writing things down for those of you that are truly brilliant and notice these things right away. But some of us aren't. I mean, I have my days. I can get this smart by not writing anything down. And again, oh, shocking. Another arithmetic sequence. We've seen a lot of these, folks. I don't know what I was thinking in putting this many easy arithmetic sequences as on here. Sequences is. Maybe I should have put some more, like, should have put like a 7th degree polynomial on here just to make you guys, make sure everybody hates me. Aha! Here's one that's a little bit more challenging, but hopefully you notice this right away as rational. And again, for rationals, we're going to think about it as the product of 2 sequences. One sequence is just the net, is the signs. And in the signs sequence, this is just a geometric. The R value is -1. So we have -1. Oops, I forgot my equal sign here. Equals -1 times -1 to the n minus 1. And just like before, adding the exponents, I have -1 to the n. Except for some reason, this turned from an h sub n to a u sub n. I did not mean that. I meant h's. And then my k sub n is going to be just the number part. So 2, 4, 6, 8. Who do we appreciate? Not all this homework assignment. So I notice here that this is really easy arithmetic sequence where we're adding 2 each time. And hopefully you can see that that's just 2n. Again, I wrote u's instead of a k there. Silly me. So u sub n is -1 to the n times 2 to the n. Next one, 17. Are you tired yet? I'm getting pretty tired of this. 0, 3, 8, 15, 24, 35. Being a student stinks. So I'm going to notice right away that it's not geometric, so I'm going to look to see if it's arithmetic or polynomial. And hopefully by now you notice that it's a polynomial. And in fact, it's got a second common difference. So the polynomial that we're going to be writing is of the form an squared plus bn plus c. And to solve that system for my a, b, and c, I'm going to have a system of 3 equations. So when I plug 1's in for the n's, I get 1a, 1b, 1c equals the first term, 0. When I do it for 2's in for n's, I get 2 squared or 4, 2, 1, and then equals 3. And the last one, plugging 3 in. I'm going to get a matrix of that form. Fire it up here. Just go over and edit my matrix. And the only thing that changed here was the last column. Changed 0, 3, 8, and second and enter brings up that last command. So again, -1.6 to the -13. I interpret that as 0. So a u sub n is n squared minus 1. And maybe some of you guys noticed that right off the bat. Go with a calculator. The next one is 18. So I have -1, 0, 1, 8, 27. And some of you guys may notice what the answer to this is already without having to do this, but let's pretend we're not so clever as some of you smarty pantses. And do it the, well, let's say the long way. Obviously not geometric with that 0 stuck in there. Oops, that's not a +7 there, though. That was +6, right? 1 to 7 was +6. And now I have a third. So this is polynomial. And it's a third, so we have a degree 3 polynomial. And we'll set this up in the same way. And again, I'm going to not show all of the system, but hopefully by now you guys are getting as sick of this as I am. But hopefully also, in addition to being sick of it, you're getting really stinking good at it. It's a funny way to draw a 4, Mr. Kulik. Did you almost draw a 2? I did. You caught me. And we know that our resulting matrix is going to be of this form. All I got to do is plug this now into old Kelky McKelkertrons and ask him for our help. So now we have a 4 by 5. Fortunately, I'm going to have to type all this stuff in all over again, which I don't love, but, you know, as compared to doing this by hand, oh, I love it. Because doing this by hand, that's going to take quite a good chunk of time, and the probability of somebody like myself making a mistake, pretty high. I'm really good at making, like, dumb mistakes. I know, right? It's like, Mr. Kulik, you're a math teacher, you're not supposed to do that. It's like, well, you know what? Like, the better I get at math, sometimes the worse I actually get at arithmetic. Seems weird, but that's what I do. Anyways, so again, this is my A, B, C, D coefficient. So the answer here is n to the third minus 6n squared plus 12n minus 8. And I hope I'm almost done here. I saved all these hard ones for last, it looks like. 19, 4, negative 9, 14, 19, 24. That's supposed to be a 4. I can't write. I'm just getting tired. It's past my bedtime. So that's minus 13. Wow, Mr. Kulik. Are you serious? I'm serious, guys. That's weird. So what's that? That's plus 36. That's minus 28. And that's plus 0. Oh, boy. Did I make a mistake on here? It's quite possible. So that's minus 36 and then 28 more. That's minus 54, and that's plus 28. Oh, buddy. Well, I guess that it's whatever this is. 54 and 28 is 82. It's a fourth difference. Oh my gosh. I think that it's much more likely I made a mistake here than me expecting you to do a fourth difference. The degree 4 polynomial just makes me sad. I mean, I'm super excited for it. Super excited. REF. Oh, this is going to be huge. 1, 1, 1, 1, 1, and that first term was a 4. And then I have 16, 8, 4, 2, 1, and negative 9. So 2 to the 4th, 2 to the 3rd, 2 squared, 2 to the 1st, 2 to the 0. And then I have 81, 27, 9, 3, 1, and 14. So 3 to the 4th, 3 to the 3rd. And then I have 4s. Oh, brother. 4 to the 4th is 256, 64, 16, 4, 1, and then 19. Then I have 5s. 5 to the 4th is 625. That was a 2 there that I just drew probably pretty poorly. 5 to the 3rd, 5 to the 2nd, 5 to the 1st, 5 to the 0, and then 24. And just I threw up a little bit in my mouth while I did that. 5. Oops. And I don't know what's going to go there yet. Calculator, please help. Open up my matrix menu. We'll go and we'll edit. This is a 5 by 6, and it's so sad. What's probably more likely is I should have gone and looked at my work and made sure I didn't make a mistake, but I'm kind of sure I didn't. But I'll tell you what, again, I would not put a degree 5 on your test or your quiz or anything like that. Oh my God, what happened to my stuff over here? Where did it go? Where did it go? Oh, good. I had a little bit of a panic attack there. That would have kind of ruined my night. May have seen your teacher cry. I don't want to cry. It's a sign of weakness. It's not really a sign of weakness. You can cry if you want to. You know, I've cried before. When I hurt myself, or, you know, when somebody hurt me, I've cried. Never for math. Math has never made me cry. Oops. But other than cry tears of like beauty because it was so wonderful, that's a fib too. I've never cried because math was beautiful, although it is pretty amazing. And again, you saw what I was doing here. Hopefully that's well, that I'm kind of surprised I got integer values to come out of this. Oops. That's pretty exciting. So, the world's dumbest sequence is this degree 4 polynomial that I had you do. Mr. Kulak, is it possible you just made a mistake when you wrote this problem? Student, it's very possible because that stunk. Alright, where are we at? 2 more to go. Oh, dear God. Felt like it should have been over from that one. At least this one's pretty easy, though. So I noticed this one. You might want to say this is arithmetic, and it'd be fine to do that, but I noticed that I'm just adding 1 each time. It's 2 over 2 that we're adding. I'm just going to write it as 1. You could go through all the trouble of trying to do it as a rational, but it's arithmetic, man. I'm taking the easy way out. I'll take that shortcut home. Boom. Done. Pretty great, right? And the last one. Yes. So excited. And of course I did something like this and put one that's a little bit tricky here for the last one. This is rational. So again, for rational ones, we're going to write it as a numerator sequence. And you could recognize this numerator sequence as arithmetic really easily. We're just going up by ones. And if you can't tell what the sequence is, it's just n. You could write it, but I think it's like obvious enough that I'm just going to write n. But you could write out the work with the formula or whatever. So here we're subtracting 1. And again, arithmetic though, you think about it as adding a negative if you want. But we're just going to write subtraction symbols because it's less writing. So k sub n is n minus 1 times negative 1 plus 9. So I get k sub n is 10 minus, n, right? Negative 1 times negative 1 is 1, plus 9 is 10, and then a negative n. So, don't forget to write the whole sequence, though. So my sequence of numerators is n. My sequences of denominators, 10 minus n. Boom, done. Yay! Sequence master.